Good morning, everybody. I hope that you have found the link and you have come up here. Thank you so much, everybody, once again. And I welcome once again everybody in this webinar on programming fundamentals for non-techies. So you can let your friends know that it has started. Those who are watching, I'll be thankful to you. Thank you so much. So I request those who are watching, please let their friends know that it has started. So we'll be starting around 11:10 because there are many people but they have not joined yet, and let's see if people are coming, and we shall start by 11:10. So basically this is something very different from arts. It is something technical. It is something which is related to computer, and that to programming, and I think it is one of the most popular subjects these days, as the introduction of Web 3.0 and Industry 4.0 things. We get to know a lot about it, and we can know from these development that software programming is one of the indispensable part of the human life. Softwares are everywhere. They're in the factories, they're in the schools, they're in the government machinery, they're everywhere. So this series of webinar will help the participant to understand the web development process, and we'll be going through JavaScript, CSS3 and HTML5. So we'll give you a basic overview of what is happening there, and so that you can understand it. You get a basic idea of what things happen, how things happen, and what things there we can do that. So we'll start by 11:10. We'll wait for the participants to join, and if I'm audible, please let me know. If the the audio is reaching you, so please let me know in the comment section. Hi everybody, once again I welcome, and good morning and good afternoon as well, those who are watching from Philippines and Indonesia and other parts of the world. So good morning and welcome once again, and please let me know if my voice is audible. Thank you. And yes, let me tell you, this would be a session very different from the previous session that we have done. Those were related to English language particularly. There were few grammatical things, few literature things, and many more that were coming up. And here the things would be a little bit different, because here we would be learning the logic, we'll be understanding new languages, we will understand the keywords, and we'll understand the logic, we'll understand the fundamentals which are there when we develop a software. So here we'll be discussing about languages, what parts of languages, or what things languages can do. I mean, what processes, what are the actions, what are the attributes that language can have, and that can help us to achieve that. The simple example is calculator. That's one of the basic examples, like where we calculate, we put numbers and we click some buttons and the result come up. So that's a software only, and that is written using a software developing language. And please let me know, let your friends know that it has started. And before going any further, let me tell you, there would be 3 parts of this session. First would be the discussion, of course. Second would be the feedback form, and third would be certificates. Yes, I'll be distributing the certificates for this session to all, and yes, I'll be giving you a feedback form at the end of the session. You need to fill it up, and as soon as you fill it, you'll receive the certificate for this session. So please write the proper email ID and the name which you want to be published in the certificates. Okay, and if you write a wrong name, that would be published in your certificates. And I'm requesting that you would write your name as you wish to be published. Please do not make any mistakes, because that would come up in your certificates. And yes, please let other people know that the webinar has started. So this is just an overview. It is not an in-depth session because we have got 90 minutes only. So but it will let you know what happens in software industry, what things are there, how to manage things, what software programming does. And if you want to get any updates regarding these things, so you can definitely visit our web page, Facebook page, which is Educationist. I'll be sharing the link there as well. And in the feedback form only, I'm talking about the feedback form. So in the feedback form, you will be given the option for writing your name and email address, and there you can fill it up. And once you'll fill it up, you'll start getting the certificates. As soon as you fill it up, in few minutes you'll get the certificates mailed to your email ID that you have put into the feedback form. And yes, please let other people know. Yes, it will be there on the YouTube channel. So anyways, you can watch anytime, but live is totally different experience. And yes, okay, let's see if it improves. Has it improved? Hello, is it okay now? Am I audible now? I think I'm audible now. Please write in your comments that it is audible or not, and so that we can move ahead with our session. So let me tell you once again, there will be 3 parts: the session, of course, then there will be that thing, feedback form fill up, and then the certificates. So your certificates will depend on your feedback form, like what have you filled. I mean the name and email ID. It means the name and email ID that you have filled, and you'll receive the certificates as soon as you fill the feedback form. And please let your friends know that the webinar has started. And I request everybody to please share so that, and we'll start by 11:10, that what I have already discussed with you. We shall start by 11:10. Thank you so much. So this series of webinar is technical series, apart from what we have been doing since very long in the past. So this would be focusing upon the technical subjects, which is computer programming. And let me tell you, it is not difficult, it is easier, and because it also involves some kind of language, that language would have its vocabulary, that language would have its functions and attributes and all that thing. So we'll be discussing all those things which are important from the perspective of a developer. And this series would would make you aware about the web programming concepts. And we have not used any server-side programming here. It is client-side scripting languages only. So you can say it is almost like the design part that you see, like when you open www.google.com, and whatever you see, okay, so you can, by learning the things there in the webinar, you can yourself design that page. Of course, you can design a page like Google by learning these things, which will be completing in this webinars. And not only this, you will get an idea of how things move around in a software programming. So what is there, and I think most of you know like what happens behind the scenes. And so I'll be at the end of the session, I'll be sharing the feedback form, and if when you fill the feedback form, write your name properly, write your email address, valid email address, and you'll get a certificate mailed to you in few minutes. Okay. And yes, and if you and yes, it's almost time, so we'll start by 11:10. Thank you. And yes, so we'll start now, and I request all of you that please share the link with your friends so that they can also, like those like who have registered, they're not here, and you can share with your friends. So it's time, we shall start. It's already 11:10. So the topic for today's session, as we all know, is fundamentals of programming languages. So programming in itself is a very popular word in the computer sphere, and developers are pretty aware of it. Technical people, technical guys, those who have technical background, they are pretty aware of it. But I let me tell you, it is not a tough kind of study to do. Anybody can do it. And the thing is, you need to develop some sense of logic. Okay, so software developing is easy. Like, you can develop. It is like drawing a thing. Okay, you will be giving some. You will be given some chart. You will be given some diagram, and you have to write the code according to the diagram. So that part is pretty easy. That part is particularly pretty easy because we have to just copy paste. We have to see the diagram. Most of the time it is a UML diagram. UML stands for Unified Modeling Language. Like there would be symbols and there would be things, and we just need to interpret it and write in the code. But that part is very easier because you learn the language. It's like you learn the language. Like if you learn a language and now you are starting, you are reading a book. Okay, that's what software developers do. But the main thing, the main brain, the main agility of the brain is tested when logic has to be developed. Okay, so you'll be given some problem, and you need to write a logic on that. So there itself the brain comes into picture, and that is the heart of the software developing, where people come, sit, brainstorm, and develop some logic for it. For instance, the example is write a program where you can find prime numbers among a series of numbers given to you. So what kind of logic you would write? All right, or you need to find the even number or the odd number. That's pretty easier. Or somehow you want to find like if we take hard example, some Google, take example from Google. Like if you want to find in 1 crore photos, like which photo belongs to which photo has the cat, okay, which photo has the dog, or which photo has a cow, or which photo has an elephant, which photo has a donkey. Okay, so this is a higher level logical things where artificial intelligence, big data, cognitive computing technology, these things come into picture. So we'll be talking about basics of programming. So basics of programming would be like what every software developing language would have at minimum, what they would do at minimum. So there are n numbers of software programming languages in which you can learn and program, and they can produce most of the time similar results. Okay, for instance, there is Java, there is C#, and there is JavaScript, and there is HTML, which is markup language. Then you have Python, you have PHP, you have ASP.NET, you have other MVC, ASP.NET MVC, all these things are there. So ASP.NET MVC, it's not a language, it's a framework. ASP.NET, again, it's not a language, it's a framework. C# is language, Java is language, JavaScript is language. Okay, and Python, of course, it's one of the languages. So let's see what do we have in today's session. So these are the list of the topics that we will be covering. We will be understanding what is programming. Then we'll move on to understand software development methodology. So there are plannings. So it is basically software development life cycle. Like for instance, if you want to go from place A to place B in a metro, so how somebody would tell you, right, to do that. Okay, so we need to go to the ticket counter, buy a ticket, this much money the ticket will cost this much money, and then we need to move ahead from there and go to that direction or that gate and board this or that metro, or this number metro or that metro, and then you get into metro, and after 6 or 5 stations that would come. So these are the steps involved. Similarly, there are steps involved in software development methodology. These steps are fixed, and these steps are sometimes sometimes are played with. So when you play with these steps, and then there are many methodologies that comes into picture. Number one is waterfall, number second is agile. So we'll look into brief what is waterfall development methodology, what is agile. Agile is very popular. Agile has been used, widely these days. In fact, most of the technologies, most of the languages use agile. And then there are data types. We'll understand what are data types. Then there are arrays, loops, functions, debugging. Okay, and all these things we know. Data types are important because these are the container. Then there are arrays. Arrays are also data types, and that's a different kind of data types. And there are loops. Loops are pretty funnier and pretty important. And then there are functions. Functions are the heart of any programming language. And there is debugging. Debugging is one of the essential parts, because without debugging no software can, or no program can pass the test. So debugging is basically testing. You can say it's a grammar check for the industry, for any language. Okay, so here we have the grammar checker, here we have the developer, and here we have other things that we will see. So what is programming? Software development methodology, which includes waterfall, agile. There are many, but we have chosen two. Then there is data types, arrays, loops, functions, and debugging. So these topics we will be covering in this session. And I request everybody to let your friends know that this is, the session has started. And yes, and let's move on to the next part. What is programming? So I think it is pretty clear which is written. So if you read it once, you'll understand what programming is. So programming is basically a process of writing a program. So it's a process. It means like when you're writing something that doesn't become a program using programming language, there are many things involved. Okay, you need to write, you need to debug, you need a platform, you need an IDE, integrated development environment. Okay, so programming is a concept, or you can say basically it's a process whereby a programmer writes a program, and program requires these things: a platform, a programmer, a programming language, compiler, and IDE. Platform is where the program will be developed and where the program will be deployed. Okay, for instance, when we do www.google.com and a web page comes to our web browser, so that is a program. Okay, so how that thing would come up to you, okay, and what would happen, okay, when browser will render the page. So all these things come under programming. So you might be confused about what is programming and software. So that is like a wheel and a car. Okay, so you can imagine what could wheel can do to a car. I mean, how wheel belongs to a car and how car belongs to wheel. So this is the main difference between program and software. So software is a bunch of program, or you can say it's a big program, it's a bigger program that has all that things involved there. Okay, so it's a process of writing a program. So program is, suppose you want an addition of two numbers and you are asking from user, okay, give number A, you entered number A, okay, like in the Google only. Like if you open Google, okay, so there are options, you can do calculations. Okay, so you say 45 plus 49, Google search, or something happens, the result comes out. So that's a simple program, that's a calculative program, that's a program written, okay, somewhere in the JavaScript, using JavaScript, because that's an online platform that server side and client side technologies used there. So in that case, web programming has been used there. And so basically program is something which is executed by computer. It is not executed by humans, it is executed by computer and it is run by computers. Unlike what we do, like we process the language, okay, in our brain and we do something. But programming is something which is not for us, okay, it is for the computer only. It is the computer who has to deal with, that will deal with the programming. Computer knows what to do with the programming. We just know how to write a program, how to, ornament a logic, but we do not know how to execute it. Of course, we have written how to execute it, but the actual execution is done by the computer. Okay. So what is programming? It's a process of writing a program, and there are few requirements. A platform I already said. What would be a platform? A machine where the program would run, and a machine where the program will be created, or a machine or a software where program would run, and a software where a program will be created. A programmer, of course, it's a man, or you can say it's the software developer, like who would be a programmer, who knows a particular language and writes it. That's a programmer. And a programming language, which is the most essential part. You need a programming language too. That is very common. I think you know what it is. Okay. And the most important part is compiler. Okay. Yes, you'll get all these things. And the most important part is compiler. So what compiler does, we'll see, because it is which bridges the gap between what humans can understand and what computer can understand. Okay. And most of the programming languages are generally in English language. So I think computer can understand English. No, computer cannot understand English. Can computer understand English? No, it cannot understand English. It can understand in the language of zeros and one. It can understand digitalizations. It can understand the things which are coming up in a binary code. I think you are aware of what is binary code: zeros and one on-off signals. Okay, so that's not the matter. You need to have a basic overview of what is happening, and in depth. This is not an in-depth session. You'll get an overview, basic overview, so you have a proper idea like what is happening. So you won't get fooled by somebody. Okay, so platform is there, programmer is needed, a programming language is needed, a compiler is needed, and IDE. IDE stands for Integrated Development Environment. Okay. For the best example is college is our IDE. Okay. Where we learn, where we do all the things, where we execute a lot of things. Okay. Where we execute the playing, where we execute talk, where we execute friendship, where we execute a lot of things. So similarly, for a programming language, IDE is a college. Okay. Where it grows. Okay. Where it is executed and where it runs. Okay. So that's the main difference. That's the similarity between it. Okay. Okay, so platform, programmer, programming language, compiler, IDE. But it is optional, because we can study in our houses, right? And we can study in the college. Okay, we can study from IGNU, or we can do distant learning right away. Okay, so you can write your code. Okay, in a software, you can write a code in Notepad, as well as you can write in a code which is a very very developed software. For instance, Visual Studio. Okay, Microsoft Visual Studio is an IDE, which is a software dedicated for the development of softwares. Okay, that is IDE. And so you can get an idea. So what happens there? Okay, so IDE is what, like we were talking about, it's a space where programming languages grow. Programming language got debugged. Programming languages are converted to what machine can understand. Okay, compiler, we'll be learning about compiler in a bit, because that is the most important part. And let me tell you, every language would have its own compiler. Okay, so let's move on to the next part, which is program. So we understood the programming, and now we come to program, and we came to know a little bit about program there in the last slide only. So in this slide, we'll understand what is a program. First point is, it is a set of instructions. Now we would confuse what kind of set of instructions. So set of instructions which are given in terms of any programming language. Okay. It is generally to do platform is a bigger term as compared to IDE. Okay, IDE is a software, but where the software would run. Software would run in a computer, okay, on a computer, okay, or a software would run on a machine, right? So IDE is a software. You can say it's a baby platform for IDE, okay, but a platform is a bigger part, bigger structure where your IDE would run and your program would run, okay. And yes, we'll move on to the next part, which is it is a set of instructions and written in any of the programming languages, generally perform a specific task. It is executed by the platform, okay. Now here the platform is the machine, okay. And when we compile, or when we when program becomes what a program should be, it gets an extension of .exe or .f file. So you would understand what is exe and app, okay. So like we have like if you have gone through the extensions of for text file, we have .txt. For document, word document file, we have docx extension. For programming language, okay, we have pptx extension. So these extensions let computer know like what type of data it is, okay. So program is also a data, okay. It is executable data for any platform, and it is generally denoted with .exe extension on Windows platform and .app extension on Mac platform, okay. So don't confuse with platform. Platform here means the playground where your software can run, okay. And you can imagine like to software to run, we need like for instance we have a audio file, but where it would run, okay, it would run on computer, it would run on some other media players, or it would run on MP3 players, portable MP3 players, on mobile phones. Similarly, a software has to run somewhere, okay. That somewhere is platform, and IDE is a small platform where you develop the software, okay. So let's move on to the next part, which is programming languages. And programming languages, generally it uses alphabets from English language, and they have their own compiler. We'll understand what is compiler is, and most of these are platform independent. Keywords or the vocabulary has to be learned, okay. So need to understand this thing. Programming languages uses alphabets from English language. We'll see how, and have their own compiler, okay. Every programming language would have their own compiler. For instance, for French language, it has its own grammatical rule. English has its own grammatical rules, okay. Spanish has its own grammatical, Sanskrit has its own, Hindi has its own grammatical rules, or Philippines has its own, Russian has its own grammatical rules. Similarly, every programming language has its own programming rules, okay. Language rules, grammatical rules, and most of these are platform independent, which means you can code on Mac PC, you can code on Linux environment, you can code on Windows environment, okay. So these are different operating systems, okay. They have their own kind of stuff, they have their own things, okay. They have their own way of working, okay. So every programming language would have a compiler, and we'll see what compiler is. And keywords and the vocabulary has to be learned. That is the most important part. You need to learn the vocabulary of any language. You need to learn the keywords of any language, which is essential, because to say something in English, we can say, if you want something, you say I need to if you say something like I want a glass of water, okay. So these are keywords. Want means something that you desire, glass of water means something, okay. Similarly, in programming language, there are set of keywords, fixed keywords, that will let the computer know that you want this or that. Okay, so we'll see examples of programming languages. And so this is one of the programming languages, okay, which is called C#. It was introduced by Microsoft, and this is a programming where two numbers are being added and it is shown onto the screen of the laptop or PC or whatever you have. Okay, so you can see what it is there, how it is written. I think it is written in English. I'm sorry, it is written in, I don't think it is written in English language. So that's public class exercise 2, public static void main, system.console.writeline, and angular braces are there. Curly braces are there. Okay, so these are the set of keywords, just a few. There are many thousands of keywords, but these are set of keywords, okay, where you can see how it is similar to the English language. Then is Python. You can see how it is similar to English language. Again, we are doing what? We are writing a program to calculate two things. Calculate the addition of two numbers. Okay, and then Java. You can see how we are doing that. In JavaScript, that's a code from JavaScript that we'll be learning in the last session. And then we have HTML. So it's a markup language, and you can see how HTML codes have been written. So let's go back to the first language, C#, and compiler is CSC, C# compiler. And then we come to Python. Python has its own compiler, PyCharm or PyDev, and then compiler JavaC. Java has the compiler called JavaC, that is Java compiler. And JavaScript, it is interpreter, which is JavaScript engine. Yes, those were interpreter. You got right. And then HTML, it is interpreted. Okay, and you need not to think about that unless you are a compiler developer. So you get the compiler, and compiler is also a program again that checks your whether the code has been written correctly or not. Okay, and then we move on to the most important part, because this program nobody can write a code. So compiler does what? It converts the human cognizable programming language into what a computer can understand. Similarly, what it does, it bridges the gap between what humans can understand and what computers can understand. Its duty is to read the programming language written in, the programming written in a way that humans can understand, and convert into something which computers can understand. Okay. So again, it is a program. Please mind that it is also a program. And then the thing is, compiler converts all the code at once, unlike interpreter, and it displays error after conversion, works on the entire program. Okay, so these are the few features of compiler. Let's move on to interpreter, and it does the same duty as compared to interpreter, and it is also a program and converts the code line by line. Okay, and then it shows errors of each line one by one, works on single line of code, and so on. So basically what compiler does, compiler converts these language into something which computers can understand. Okay, and different language has their own style of compiling. And interpreter, there is a difference between compiler and interpreter. Compiler converts the whole language, whole bunch of code at once, and gives you error. Unlike interpreter, it goes line by line, and if there is error, it will show the error and it will not move on. Okay, so that is what happens with JavaScript. Okay, when we learn JavaScript, we'll understand what happens there. So interpreter and compiler are pre-designed program. We need not to design it. For instance, like we are writing a program and then we are writing another program which will compile it. That doesn't happen. Okay, so software engineers, those who own these programming languages, will give you a platform and will give you the compiler as well. Okay, so you can go and convert it into whatever the computer can understand. Okay, and then the main important part is software development life cycle. Okay, so we'll understand how software development life cycle works, what happens there. Okay, and so it starts with planning, then there is analysis, then there is design, then there is implementation, then there is testing and integration, and then there is management. Okay, so these are the basic steps which are involved in software development life cycle, because now this has become an industry. We are selling the software, somebody is developing a software, somebody is buying the software. Okay, now if you have your own business, you can understand what I'm saying. So you would have some needs. For instance, you have customer and you have some inventory and you have some other things related to your business, and you want your software to be developed. So in that case, you do what? You want to automate it, right? Like suppose you have let's take an example of Amazon. What we do on Amazon, we go on Amazon and what we select what we want to buy, we put it into a cart and do what? We make a payment or do cash on arrival or whatever it is, and that thing arrives to our house. Okay, and we pay if it is cash on arrival, or we pay if it is already if it is prepaid things. Okay, you have to pay it advances there, or to make payment, or cash on delivery is not applicable, so we pay it and things would come. So that is an automation thing there. And Amazon would have gone to, the owners of Amazon would have gone to some software development company and they have told their requirements, and this is how the software development team has come up. So those team would have gone through all these stuff. They must have done planning, then they must have analyzed the things, then they have designed the software then in small programs, and then implemented that program at the client side or their side, and they have done testing. Okay, and then there is maintenance. Okay, so those who own bike, you know what is servicing, and the servicing here can be compared to maintenance. It is the same thing that happens here. So let's see what requirement analysis and plan phase are. Now what it does, relevant information is collected from customers, then analysis carried out to check the feasibility. Software develop requirement specification document is created. Okay, so this is what happens. Like, okay, so requirement analysis and planning, we have information is being collected from customers. Okay, then analysis, like how they would create the things, how they would manage the things. Okay, and how they would how much the customer can pay, or how much their capacity is, like how much time it will take. Okay, all these things are analyzed, and then software requirement specification document is created. Let's see how that document looks like. That's one of the examples. So you can see there is purpose, overall description, specific requirement. So you can see what happens there. Okay, so it is one of the software requirement documents where we gather the information. The software team would gather the information. So let me tell you, this is an interaction between a software development company and a customer. Okay, customer has its own requirements and now they are interacting with each other. And the first phase that would be used by software development team is requirement and analysis, where they create software requirement document. Then the design phase come up. So after the SRC has been completed, and then they create the blueprint of the software. For instance, for Amazon, what they would have created an interface where the things would be shown on the laptop, and the categorization of the things, search engine installed, all these parts would be designed in a, you can say, in some language. So here it's a designer language. As I already said, it is, you can use UML, uniform resource language, okay, uniform modeling language. There you can define use cases and logic and loops and everything, okay. So it's just a blueprint. So this is the most important part, where you put the logic, okay. This is the thing, this is the part where brainstorming has to be done, where people sit and they brainstorm and they get to know like what is happening. Then comes, so this is one of the designs you can see. Now this is a design which tells you about how email communication can be established, okay. So you can go through it and check what are the things they have used. So there is send email, then there is receive response, okay. Then there is condition, whether it is private or not, whether we need to give some confidential, send some confidential information and do what, or it's a regular mail to do what. And then there is a response, receive, what to do, what not to do, okay. So these are the design which, you know, created in design phase. And then after that, implementation of coding. So it is similar like reading a book. You have a design and you are creating the code, okay, because you know, like if the design is like this, what you need to do. And design can be implemented in any code, I mean any languages prescribed by the company. So the beautiful question for software developers are which language to learn. The thing is, you cannot decide, it will be decided by the company, because company changes languages, because company do migration training also. Like one time we were doing C#, but the next time we need to learn some other language, probably Java, okay. So that's very dynamic. So implementation, design part, the blueprint of the code has to be, for instance, like you have been given, for instance, like a question paper is the blueprint of your answer, right? What is your name? Suppose question comes like UPSC, like those who are preparing for UPSC, write something about Atmanirbhar Bharat, okay, or write something about the PPP things, okay. So what happens in this yojana, okay, PMJ yojana, what happens there or what happens there. So these are the blueprints and you write it down, or critically examine, or critically do that, or examine, analysis. So these things tell you what? These things tell you what to do, what could be there. So similarly, the design part tells the software developer that what kind of code or what parts of code you have to use. Then there is testing. Once the code has been developed, once the software has been developed, you need to test it. I think most of us are aware of vehicle testing in manufacturing plant. When they have, you know, manufactured a vehicle that is ready to go, then they test, okay, like they try to, you know, break it, they try to hit it, they try to, you know, demonstrate some, or they try to copy the accidents by, you know, sending their vehicles against the wall, or, you know, throwing their vehicles against the wall, or vehicles getting hit from the either side by some heavy metal or whatever you can see. So these are called testing. So similarly in software development, once the software has been developed, they do a rigorous testing, okay. And if it is a fault is found, and any fault is found, it is given back to the developer to cure it, okay. So there are many types of testing, but you can see there are functional, non-functional, maintenance testing. So there is unit testing, there is integration testing, smokes and user localization, globalization, interpreting, performance, enhance, load, volume, scalability, usability, regression, maintenance. All these are testings which are done. So the main motto of testing is to find for errors, okay. For instance, you're developing a software where a guy would enter his email ID, but instead of email ID he wrote his name. So how the software would handle that? Suppose it is asking for age and somebody wrote 200, so that's not a good case, right? So how would these things will be handled? Okay, so next is deployment. As you can understand, the software is taken to the client side and it is deployed in an artificial intelligence mimicking the artificial environment, mimicking the environment where actual things would come up. Okay, so here client also tests it and developers also test this. Okay, for instance, you run an online academy, okay, and now you have ordered a software for it, and now the software has been developed, and so the software will be deployed on your machine. Okay, and now you'll tell few of your students to enroll through it, okay, and check it out, or developer would do the same, and then they will do what? They would check out. They would do what? They would check out whether some error is coming or not. If it comes, it goes back to the software development company and it cures it. And then maintenance is like sometimes, like, you suppose the database of the software is can hold 1 GB of data, okay, and suppose it has increased, or it so that and it can crash. So that's the maintenance part. So what would we do? Okay, or some user had put some virus in your software, and what would you do? So maintenance, all these things come under maintenance. So based on all these things, there are two software development methodology. One is waterfall approach, one is agile approach. Waterfall approach, it's a linear approach. So it says that when one phase has been complete, then only you move on to the next phase, and then only you move on to the next phase. Okay, so this is the linear phase. Requirement is completed, then you go on design. If design is complete, then you go on implementation. Implementation has been completed, then go verification, then maintenance. So this is what they say. And then agile is continuous iteration, development, testing throughout the software development life cycle. Development and testing activities are simultaneously. Okay, agile works like this. Suppose somebody has given you to develop 4 parts, okay, of a software, and you developed one part, or instead of waiting for all the parts to be assembled together and given, you give your software with one part and you tell you use it, and will be updating it soon. The most good example is, the best example is Google Chrome or Windows 10. Okay, you see updates are going on day by day, right? After 1 week there are updates. What are these? So using the software, but at that same time it is getting developed. It is not a developed software, it is getting developed. Okay, so you can see the diagram for agile methodology, and then you can see how it happens. And now we'll move on to the data types. Basically, data types are container which contains the data when you're in your language. Okay, sometimes you need to deal with the data. Okay, and so in that case, what you would do? Okay, in programming language you need to deal with data. Suppose your programming language takes the biodata from a person and saves into its hard drive or some backend software or a database. Database is what? Database is something where we can store the data in a very logical and a very retrievable way. Okay, suppose there is a name and there is age, then there is some text, and there is email ID. So there are different kind of data. So how the programming language would hold data? Programming language cannot hold data unless it has data types. So these data types are basically keywords that let the computer know that what is the type of the data, okay, and how much memory it will take in on the RAM. Okay, that's clear. Data type, it's a container basically where data is saved. Okay, data can be any type. Okay, and data types is predefined. Data types are predefined there are different data types for data which is numeric, data which is character, or data which is some other character. Okay, so you can see there. So data types are basically, so you can see there are two kind of data types basically, primitive and non-primitive data type, and you can check it out. Boolean is a data type, numeric, and then you have character, integral data type, then you have boolean, char, byte, short, int, long, floating, non-primitive, you have string, array, etc. And we'll see what's the difference between primitive and non-primitive. So it depends on the softwares. Okay, it depends on the, the language. I said software, language that we use. And there are different data types in different language, like C# support integer, Java support something else for integer. Okay, so basically data types, once again I'm repeating, it tells the computer through a program, through a language, that what kind of data it is, okay, and how much space it is going to take. That's the duty of data type. Okay, so let's see what is happening. So that's a C# code. You can see int a, int b. So int is a keyword which denotes a data type in C# language. In Java there could be different, in Python it could be different. So when you say int a equals to 10, then it is telling the computer that int is a type of integer data and it will take this much space, and the value it is storing is 10. Okay, and then if you talk about primitive and non-primitive, two types of memory come into picture, stack and heap. Okay, stack is limited, heap is unlimited. So stack keeps the reference. Okay, so you have to see that those data type which are reference data type means their actual value will be stored somewhere else, but the value where it is stored has an address, and that address will be stored in some other place. Okay, in fact its address will be denoted by a thing which is stored in some other place. For instance, in stack, if you say class object new object, so obj generally is a data type of reference. So the main difference between reference and non-reference data type is value type or reference type is value type data is stored in stack, like you can see A10, B10, whereas reference type data, the address is stored on stack and the actual data is created on the heap, because reference type can have multiple types of data. Like those who are aware of object-oriented programming, and there can be numeric data, there can be character data, there can be decimal data, and there can be n numbers of data, and so on. So it is stored on the heap. Okay, so stack and heap, it's a part of running memory. You can say you can compare it with the RAM. Okay, and then there are conditions and operators. Every programming language in the world would have these parts, conditions and operators. So understand it. So those who have run mixer grinder, they would definitely understand it. Like how we do it. We put, suppose you want to churn the sugar, so what you do, you take this much of sugar, put it, and you on the mixie, and after some time you stop it and check whether it has been churned or not, and you'll check, yes, it has been churned or it has not been churned. If it has been churned, you stop it and put it somewhere else. Okay, but if it has not been churned as desired, you do what? You keep on, you then put the thing there and you start again, right, until it is being churned, right? Until it is churned as desired. Okay, or until it has been crushed as desired. So your conditioning are coming up, whether it has been churned or not. If it is churned, do that. If it's not churned as desired, do this. So conditions can be very beneficial. It's an integral part of software engineering. Any language. Suppose suppose you want to write a program where you tell whether a person is old or not. Okay, and you would do what? You would use conditions there and operators. What are operators? Operators are mathematical symbols that has some meaning. Okay, remind that these all things are written in a compiler. Compiler knows all these things. Computer doesn't know before the compiler. Compiler know all these things, and then it creates something which the computer can understand. Now, for instance, there is a if condition. Okay, now you can say if the age of man is above 50, he's old. If the age of man is above 60, he's old. If it is below it, it is not old. Okay, so you can say if age is greater than 60, then old. If age is lesser than 60, not old. So this is the condition you can use in the software development, in any programming language. So in C# there is a keyword called if, and you can specify if age again is a data type which is holding the data coming from the user. Age is greater than 60, you write something. Okay, so this is how the things work. And then loops are something, sometimes you need to execute a code, execute a statement more than one time. Okay, for instance, like you can say yes, people are leaving, not an issue. So you can say, like instance, like suppose you want to write, name of 1,000 people, okay, one by one to a screen, okay, to a computer screen. You can do that. Okay, so one way is to do what? Write manually all the names in a programming language and let the programming language to print it onto the screen. But how much time it will take? For instance, if you take 30 seconds writing a name of 5 seconds and there are 1,000 names, it can take time. Or else you can do what? You can collect all the names and let a loop run, and you tell that loop that you start with 0 and end in 999, and you write the name which are there in a list which you already have. Okay, so you can do that. In that case, you can use loop. You tell the loop that you have to run this much time, and in loop will run this much time, and the things which are written inside the loop will be executed repeatedly until the condition has been met. Okay, so these are the features of loop. And then you can check, that's a logic diagram. You can say it's a UML diagram for loop. Okay, and then functions, these are the building blocks of any language. So these are basically actions. So when you click Google search button, that's a function which is running behind the scene. Okay, when you switch on your computer, that's a function running behind the scene. So anything which does action in a software, in a programming language, it's a function. Okay, and you can define function, and you can write your code inside a function to do something. Okay, so if you remember the first example of programming language where we saw C# language, where we were doing all these things. So there was public void exercise or something like that. So that is a function where you are executing something, we are doing some action. So functions are basically those chunks of code, okay, where you can do some function. So you can see it can be tailor-made. There are predefined functions as well. Definitely compiler would have given you some functions, and it is block of organized reusable code that perform a single specific action. Okay. So it's a reusable code. You can reuse it as many times as possible. Okay, and then so this is example of a function. What we are doing, we are calculating, we put number 1, we put number 2, and we said plus, and we said equals to. When we click on equals to, something happens. So equals to would have some function running behind it. It's back. Okay, so let's move on to the next part, that is debugging. It is the last part of this session, and after that we'll share the feedback form and I'll be concluding the session. So debugging is a feature which is implanted in integrated development environment. Okay, or you can say your compiler also helps in debugging. But IDEs would have better understanding of debugging. It will let you which line of code is giving you error, where the error is coming from, what's the error. So basically it will tell you how the compiler is compiling the things and where the errors are coming up, so that you can go and check it out. Okay, for instance, you have told a loop to run for 50 times. Okay, but loop is not running for 50 times, it is running for 45 times. So what's the issue? Okay, so you can check on debugging what is happening. In debugging you can check, yes, loop runs once, loop ran twice, thrice, 4 times, 5 times, 6 times, and when 45 something is happening, and that's why this is happening. Okay, so debugging is like this, when you go and check it out what's wrong is happening, and to improve your code, or to get what is expected from the code. Okay, so the session I have ran fast because there are few numbers of people. Not an issue, this will be there, and you have any queries you can definitely get in touch with me on email. And yes, so I think debugging is clear. So we'll conclude this session, but before concluding that, we'll be sharing the link of feedback form in the chat window itself. So you are required to fill the feedback form, and as soon as you fill the feedback form, you'll get the certificates for this session. I hope this is a very fast session, but I have tried to give you as much information as possible in this span of time. So this is what happens. Basically there are loops, then there are conditions, then there are some other stuff like functions, then there is a compiler, then there are platform things. Okay, so there are different languages, they have their own compiler. Compiler is like a grammar where it checks whether the things have been done or not. Okay, things have been reached, or things have been working in a correct format or not. Okay, so meanwhile I conclude the session. You can fill the feedback form. Okay, it's an automated feedback form, so it has a capacity, but I don't remember what's the capacity. Okay, so if it stops responding you, it means it has completed, it has been full. I'm sorry. So I have shared the link of feedback form. Please fill it up, and I will take it down by today evening, so you can tell your friends to watch and send the feedback as well. And let me know if feedback form is the feedback form is opening up, and I will mute for a second. Let me know if the feedback form is opening up or not. And if you wish, you can subscribe the channel, because we'll be doing all the webinars here only, and the future webinars also, and we'll be uploading the webinars that we have already conducted. So you can come, and anytime you can watch those webinars. And I will take back the link of feedback form by today evening, because it is limited, and probably I think 400 to 500 people can fill the feedback form here only. So as soon as you'll fill the feedback form, you'll receive a certificate. And yes, we have gone fast, but I think it is clear. There is nothing to so this is just an overview, because we won't be using all these things in HTML5 or in CSS. It's a totally different, but when we come to JavaScript, we'll be using few of these things which we have discussed, and there you'll understand how the loop would run, how the conditions would come up, what is a function. There itself you'll understand. So this is just a teaser that you'll know what could you expect in the coming sessions. But please keep in your mind that there are some data types and there are some conditions, there are some loops which are integral part of programming. And please let me know if the link is opening up. And you can tell your friends also, like it will be there in the the feedback form will be there itself in the comment section, and you can thank you. So you can go and tell your friends, like they can watch and give the feedback form, they'll receive those certificates. Okay. Sorry. So basically programming is something where we know a language and we also know what words would do what with the computer, and we use those keywords in a way to achieve something. Okay, so this is what programming is all about in a very simpler way, and compiler is there which uses, and yes, please check that you're getting a certificate or not, because the certificate will be mailed to your email ID just after you have finished submitting the feedback form. Okay. And yes, this video will be here all the time. You can come anytime and check it out. And if you wish, you may like our page, because we'll be uploading the recent webinars that we have done. We have just uploaded once. So yes, of course it will be there on this page. And yes, so please fill the feedback form. You'll get your certificates as soon as you have filled the feedback form. And thank you so much for joining. Hope you liked the session, and please fill the feedback form honestly. And yes. Yes, so yes, I hope you have liked the session, you have filled the feedback form, you have received your certificates as well. So you can share this with your friends, and so that they can, if they want, they can come and join. I mean, the video which will be there on the YouTube, they can join, they can check. If they like, they can send the feedback form. I mean, fill the feedback form. And yes, thank you everybody once again. So we'll be closing the session on like around 3 to 5 minutes now. And I know it's a fast session, but still I have tried to cover with the examples so that you can get a better idea of what is happening there. I'm not sure why less people have come up, because the registrations were very high. Number of registrations were very high. I think most of you are from engineering background, and that's good. And yes, thank you so much. We'll be closing the session now, and see you at tomorrow's session. Bye for now. So tomorrow's session is on HTML5, so that would require some contribution from your side as well. Like once I finish, I'll send you some code to run to check it out whether it runs or not, and yourself, so that you'll learn better. Okay, thank you so much for joining. And yes, if you wish, you can like the Facebook page, which is Educationist. It's there on the Facebook, and you can check. Yes, thank you so much. Bye, see you tomorrow.